In this video, we're going to look at the interior angles of polygons and the exterior angles of polygons. So the first thing we need to look at is what is a polygon. So the definition is a polygon is a two-dimensional closed shape with at least 3 straight sides. So the key thing there is that the sides are straight, so there's no curved. So here's some examples of polygons. We have a triangle, we have a irregular octagon, and we have a irregular hexagon. So that all the sides are straight, none of the sides are curved because that would not make a polygon. So what we're going to look at first is the angles inside polygons. So we're going to understand first where it comes from and how we can work that out. So if I have this quadrilateral, okay, and I need to work out what do the angles inside add up to? What is the sum of the interior angles? So let's take this triangle. We know that angles in a triangle, if I add them together, it has a sum of 180 degrees, okay? So if we can take a polygon, so this quadrilateral, and I can create 2 triangles, so I go from one vertex to the other, I create 2 triangles, and within each triangle, I know that the angles add up to 180 degrees. So let's take this first triangle. Let's say I have X, Y, and Z. I know X plus Y plus Z equals 180 degrees. And then let's say we have A, B, and C. I know that A plus B plus C is also 180 degrees. If we go back to the quadrilateral, and I know in a quadrilateral I have 1, 2, 3, 4 angles, I can add these together to see what the expression is. So if I start, we have one angle, which is Y. We have another angle, which is made up of X and A. We have a third angle, which is just B. And then we have that fourth angle, which is made up of Z and C. If you look here at what we started with, we have X plus Y plus Z, which I know adds to 180 degrees. And we have A plus B plus C, which also adds to 180 degrees, which means that the angles in a quadrilateral must add up to 360 degrees. So if you know how many triangles fit inside the polygon, you can work out the angles inside. So let's take this investigation a bit further and look at different polygons with different sides. So a 3-sided shape is 180 degrees. We've just looked at a quadrilateral, 2 triangles fit in, so that's going to be 360 degrees. With the 5-sided shape, from the same vertex, we can make 3 triangles. A 6-sided shape is 4, 7-sided is 5, and an 8-sided is 6. Now let's look at the size, how many sides a polygon has and the number of triangles that actually fit inside. Because if we'd done what we'd done to begin with, it would take far too long to work out the angles inside the polygon. But I'm going to use this table to help me explain. So we have different names of polygons, triangles, quadrilaterals, pentagons, hexagons, heptagons, and so on. If you know the number of sides a polygon has, if you notice, the number of triangles that fit in is 2 less. So regardless of the number of sides, let's say we have an n-sided polygon. If we subtract 2 and times it by 180, we can work out the interior angles of a polygon. And that's where the formula comes from. N minus 2 times 180 degrees. That's the interior angles of a polygon. So let's use this information and go and answer a question. So in this diagram, I have a 6-sided shape. It is a hexagon, an irregular hexagon. And I'm going to work out what y is. So first step, I have 6 sides minus 2 times 180 degrees. So 4 times 180 degrees is 720. So I know when I add all the angles together inside, it has to equal 720 degrees. And that is a nice easy question to begin with to see what the angles inside add up to. So if I add all the numbers together, I get 110 plus y equals 720 So y is going to equal 110 for that to equal 720. So a nice easy question to begin with. What about if we have regular polygons? So if you don't know what regular means, it means that all the sides and all the angles are congruent. They are equal in measure. They are the same measure. So let's say we have a regular hexagon, has 6 sides. I say, okay, I know 6 minus 2 times 180 degrees is 720. So that means all the angles inside, if I add them together, is 720. But if it's a regular shape, I know all the angles would be the same. So I would just say, okay, well, 720 divided by the number of angles, which is 6, the same as the sides. And that means each angle, each interior angle, is actually 120 degrees. And you can do that with any regular polygon. So let's take this 10-sided centagon. I know that 10 minus 2 times 180 degrees is going to equal the sum of the interior angles. So that is going to be a 1440. But if I want to know what each interior angle is, I would just do 1440 and I would divide it by the number of angles. So each interior angle is 144 degrees. So regular polygons are quite easy. You work out the interior and then you divide it by how many you have. Right, what about a bit of a problem solving question? So again, we do exactly the same methods as we've done before. We have 5 sides, so 5 minus 2 times 180 degrees. We're going to be left with 540. If I add all the angles together that I know, so 2x plus 10 plus x plus 2x minus 20 plus 90 plus 90, it has to equal 540 degrees. So if I simplify it, I'm going to have 5x, and if I simplify the numbers, I'm going to have 170 equals 540 degrees. So minus 170 from both sides, we will get 5x equals 370. Divide both sides by 5, and x equals 74. And in this case, it's going to be degrees, which is one of the angles. If I needed to work out the other 2 angles, I would just substitute in 74 into both expressions. Okay, so let's move on. What about if we were given a question where it says the measure of the interior angles of a regular polygon is 108 degrees? How many sides does the polygon have? So this time, if I draw a rough sketch, I don't know how many sides the polygon has. All I know is that the angle inside is 108. Okay, well, if I use the formula, I know n minus 2 times 180 equals the sum of the interior angles. If I divide this by the number of sides, it will get me what that interior angle is. And this is the formula we can use that we've just used in the regular polygon questions. So if I times both sides by n, we have n minus 2 times 180 equals 108n. If I expand this bracket, we have 180n minus 360 equals 108n. I'm going to subtract 180n from both sides, and I will get negative 360 equals negative 72n. And then we're just going to divide both sides by negative 72, and we are going to be left with n equals, I'm not too sure, so 360 divided by 72 is 5. So that means my regular polygon has 5 sides, so it's a pentagon. Okay, and that's how you can work out the number of sides in a polygon. Right, let's move on to exterior angles. Okay, so when we talk about the exterior angles, it's important that you know what they're talking about. Okay, so if I extend the sides of this polygon, they are my exterior angles. Exterior angles are on a straight line with your interior angle. So if I drew them all straight lines as best as I could, okay, they are what we call our exterior. They are on a straight line with interior. They would add to 180 degrees. All exterior angles add up to 360 degrees. Doesn't matter what the shape is, because if you imagine you stood at one point and you walked around the shape, and each time you got to a vertex, you had to turn your body. When you get back to the beginning, you've done a 360-degree turn. Okay, so let's try a question. Oh, we have a triangle too. Okay, so here's a shape here, and we have 1, 2, 3, 4, 5 sides of so it's a pentagon, and I'm going to work out what y is, so nice and easy. I'm just going to add all the angles together that I know, and y, and I know it has to equal 360 degrees. So if we add 75, 95, 95, and 35, we get 300 plus y equals 360, which means y is 60 degrees. Some people prefer the exterior angle rule because I can work out any of my interior because they are all on a straight line with the exterior. So for example, if this is 95, this is 85. If this is 75, this is going to be 105. If this is 95, this is 85. If this is 35, this is 145. And if this is 60, this is 120. So interior and exterior are actually on a straight line. If we want to